So for my project, I decided to calculate the X center of gravity of a Poland Spring water bottle. To do this, I had to make a couple of assumptions first, though. The first being that this bottle cap at the top was of the same material as the rest of the Poland Spring bottle, in that if it weren't, this plastic at the top is heavier and thicker than this plastic around the rest of the bottle, and there would be a concentration of mass at the top. So I assumed that it was all the same material, and I also assumed that this bottle was of uniform density, and that the only thing that would be changing as you went down the length of the bottle was its width. It changes to around 7.6, a quarter of the way up, and then it grows back, as you can see, to roughly at 10.2 centimeter width, and then shrinks back down again. So to map out the shape of the bottle, I used the y-axis as my base and two horizontal lines to form the the beginnings of the sides, and then two parabola here to form the curved middle of the bottle, and then a continuation of those first two lines to form the sides at the top, then two different parabola to form that curved in kind of shape closer to the top, and two horizontal lines and one vertical line to form the bottle cap itself. And so that's the shape of the bottle roughly horizontally. So the next thing I had to do was to calculate the areas of sections that I divided within the water bottle. So the easiest way I figured to do this was to have the bottom section that was rectangular be its own thing, then another section be the curved middle part, another rectangular section towards the top, curved towards the bottle cap here with the two parabola, and the bottle cap finally being its own little square at the end. The scale I used here, I converted centimeters into inches because the numbers for inches were easier to use. It's kind of blurry here, but it's intervals of 2, so 2 here, 4, 6, 8, 10, all the way down to 12, 13 at the end of the bottle cap, and same on the y-axis. So the bottle base is roughly 4 units, and its length is 13. So now I had to calculate the area, and so I did it section by section. Here's the math. First I had to find out where the parabolas met the other lines, and I had to set functions equal to each other, as you can see here, to find where each section ended. And after I found where they met, I was able to use calculus and integrals to find the area of each section. So the rectangular sections were quite easy, A1, A3, and A5, and the real math came in here in A2, where I had the two parabola in the middle forming that curved in section, and A4 was the other tough one, which was the set of green parabola which formed the curved shape towards the top. So I got all of my areas here of each section, A1, 7.4, A2, so on, and I got A net to be 45.1. So now in kind of the home stretch here, I had to find the center of gravity of each section that I made up, and use an equation to find the center of gravity using the ones I found from each of those sections, and so the center of gravity for the entire object. So using these equations here, I was able to cancel out and sub in for unknowns to use numbers I actually found, and what you finally end up with is x center of gravity equals 1 over m integral x times m, a certain function, depending on which section you're doing, divided by the area of that section times dx. So I did this individually, in that xcg1 would be the x-center of gravity of a1, xcg2 for section a2, and so on. So here are the numbers you get after doing the integrals and all that math and subbing in. 0.88 for xcg1, xcg2 would be 4, so on over here. And so now that I have all the center of gravities of each section and the areas, I could put them together to find the final center of gravity for the entire bottle. And the equation I had to use for that was 1 over m sigma mi xi, and the ratio that we had set up in the beginning of this section, which is right here, m has a certain ratio to a, so you can use a for 1 over m here, and since I have the a's, and I can just put them together in this equation, and you get 1 over 45.1, and you plug in all of the mi's and xi's for the sigmas here. So each individual x center of gravity I found and its corresponding area. And once you multiply all that out, do all the arithmetic, you end with an x center of gravity it's at 6.10 inches. And in terms of the measurements I set up in the beginning, it'd be 15.5 centimeters up on the water bottle. Which kind of makes sense, because if you look back at the water bottle, which is now right here, assuming that the bottle cap is made of the same material as the rest of the bottle, it seems pretty much evenly distributed in terms of area around the entire bottle. So 6.1, which lies about right there, seems like a pretty reasonable answer. And so that's the x center of gravity. Thank you.